Hello, good morning. Thank you for coming. My name is Puertas. I come from Colombia. I'm a type designer, logo designer, and I studied here in the Netherlands, the master's course of ATypI media. What I want to talk about is something that sounds very strange and very hard to understand, and it's perhaps not the best title, but it is what it is. But anyway, it's like I feel like there is a question, and then I want to try to give an answer to it. And this could be said more easily if we asked kind of an easier kind of question. And this is, of course, how, if we can evaluate and choose fonts objectively. And this is this is where it's going. Like the title that I used is actually pointing in this direction. In order to develop this idea a little bit, I divided the presentation in 4 parts. And these parts are just like this. I want to talk about the parameters in design and some relationships there. I want to talk about what you do when you select, when you choose a typeface, and when you evaluate one. I'm a teacher, so I'm kind of interested in evaluating stuff. Sometimes my own students design typefaces, so I think it could be handy to have some sort of system to evaluate what they produce, and I also think that type designers could find it useful. And then I want to give some examples and add some conclusions. Of course, when you talk about parameters, it's inevitable to not talk about this famous cube in which we have the most important parameters that we find in type design that we can work with and we can design with them. And there is nothing new there. It's quite famous. It's quite straightforward. But what I want to say about this is that the most important things are just there. Like if you want to explain what parameters in type design are, you need to refer to this graphic, and it's almost all there. The weight axis, the contrast axis, and the contrast in these two ways, which are the amount of contrast and also the type of contrast. And so this is like the perfect example of parameters. And parameters in type design have been developed a bit more since Herr Noordzij's cube with Type Cooker, Eric von Buchlen's pedagogic model to introduce students to the topic of type design, which is not easy. And I'm mentioning it here because it is like a further development of Herr Noordzij's ideas, and it introduces a whole bunch of parameters that are really useful when it comes to design a typeface. This is really important. So at this moment, it is more or less clear that like a parameter is this thing that you can measure, and it's actually a meaning of the word parameter. If there is some feature in a shape or in a letter form or in anything that you can measure, and you put variables, and then you have a parameter, and that's I think a very nice way to see it, because as you can see, that they are very useful in type design. And there's more about parameters in type design, and I just want to mention this also very famous example. It's computer modern, the set, a big family of typefaces designed by Donald Knuth. And this is also well, very important because each letter form is defined in around 60 parameters, and that gives you the power of varying shapes, everything you want. So it doesn't matter actually like the final form. It's all in the math, and the shapes are actually very refined with these 60 parameters or so that he defined. And again, well, this is nothing really new. But what I'm going to is that type design is pure mathematics. It's numbers and it's coordinates, and there are many things that can be measured there. And so I think this is very useful to try to answer the question if we can choose and evaluate fonts via recipes or algorithms. And this is also something that I want to show because it's a close-up to a graphic made by a designer, Alan Bernard Hughes, and he's there explaining to us. This is available on the internet, and he's trying to explain what the Penosi system is about. I think you have heard about this Penosi system, and it's very interesting because it's like trying to reduce to numbers, to values, very small amount of values, and all the possible shapes that you have in a typeface, and so that you can have a code, and each typeface has this code, and this more or less unique code can be used to interchange or to substitute better fonts whenever you're missing this font. So that's another use that we have for parameters in type design, or in type, not actually type design this time. This is font substitution, so it's different. And I want to mention some previous experience of a colleague. His name is Oscar Velasquez. He's also Colombian, and he designed a game that I would very much like to show you and maybe at the end of this round of talks, because I have it right here. It would be nice to show you. It's a card game, and this card game is used to teach students like what is the highest contrast typeface within this bunch of cards, and which one is which one has the highest X height, and things like that. And it's fun, and it's a nice way to introduce the topic, I think, of font selection and parameters in type design, even though it's kind of nerdy, I have to say. These are some more pictures of the game. It's like the players compete for the highest of the lowest value of certain parameters, and that could be fun. But let's go straight to the topic of type selection and font evaluation. And I want to mention something that is in the website of myfonts.com. Probably someone from myfonts is here, and it's a way of selecting type, which is quite useful, and it's become more widespread, which is the semantic approach. And it's a semantic approach because it doesn't need parameters or anything. It's not describing shapes. It's just qualifying these shapes. It's all about like trying to put a tag on a font and trying to give it an equivalence in a given language, so that the user can find it very easy to choose. But the thing with this approach is that, of course, it might have its problems. So when I click on friendly, for instance, these are the results, and there are fonts that are very, very different, because friendly means completely different things for different users. So the tax approach also has some flaws. I decided to just to give it a shot and try to select type. It's an experiment. I'm a teacher, so it's not really a commercial anything. It was an experiment, and I thought it could be fun. And I made the experiment of selecting, for instance, a font for footnotes in a book. So let's see how it works. Let's see if we can, or what decisions we have to make, or what process, since algorithms are step-by-step processes, like what things we need to do step-by-step in order to achieve it. So I took my library. These are some of the first fonts in the library, and I just made like one biased decision, which was let's choose whatever we can call text typeface. So I discarded symbol fonts. I discarded everything that looked kind of hard to read. I was very so many fonts like text fonts that I myself have designed, and system fonts and fonts from friends are there. Just those were remaining. And then I made this spreadsheet. I measured all the values. I started with the UPM size, because if you don't start there, I realized that you can't compare anything with anything. So it was like the very first decision that had to be made in order to achieve proportions. And then I tried to calculate I put all the values, and after that I found proportions, and I tried to make them comparable. And these are the parameters I considered, and the parts that I measured. and I realized that font selection is nothing more than comparing the requirements with specifications. Like, what do you need a font to do? Why do you want to choose it? Like, what do you want to make with it? And what features this specific font needs to have. And I also found that the font selection process is kind of an intersection between sets, which is let's try to find the fonts that match this particular parameter, like have these variables between these variables, so you have to define thresholds, and the ones which fulfill this requirement and this requirement and this other requirement, and then you have the selection. So the number of options available is greatly reduced. So an attempt to an algorithm or recipe to find a typeface for a specific use or select a typeface could be sort of like this, like, okay, what do you need this for? See the options that you have and what they look like. Try to match attributes with requirements, and of course you have to repeat this process until you find what you need, until you have the options that you can handle. I also developed. I can't see much, but I also made a few graphs, like scatter graphs, trying to map where these fonts were in the space according to the comparison between parameters. So when you compare parameters, you find things that you don't expect, and I really didn't expect this. There is one diagram that inspired this, which is the Hertzsprung-Russell diagram. It comes from astronomy, and it's a diagram that tries to compare parameters of stars, like how bright they are and how far they are, and some distances can be measured, for instance, but some others are very hard to measure. So Anyway, this graph kind of tells you how far stars of a given brightness could be. So it's very interesting because it maps in a very different way the stars. It's a map of the stars. So this whole thing inspired me to do the same with the fonts and see what happened. So in order to find this typeface for footnotes, I thought it could be a good idea to search for something in there, like like a rather large X height, but a weight of stroke or stroke width which was not too dark, like slightly dark because it needs to stand the reduction, but not too dark. So it should be there, and if you fulfill this requirement, and also you can fulfill another requirement, which is the contrast amount. It needs to be rather low. In this graph also we can see kind of a relationship between the contrast amount and the relative X height of fonts. Then you have it. And these are the search results, actually like just 7, and the good thing is that some things there, some fonts there, I didn't imagine like they could be any suitable for this kind of job, which is nice. I mean, it could not be. They might not be your favorite fonts, or perhaps you don't know them very well. It's a good thing that they showed up, because it's something I hadn't thought about. And when we think about evaluating type, what we have is just a set of shapes or a word or whatever, and you have to take a careful look at those shapes, and how do you know if this is a well-designed font, or what it's good for, which is the whole point of evaluating something. So I think that the algorithm for that could be defined as something like, okay, first define the parameters, what things are you looking at. Of course, try to quantify the values, like what is this good for. Graphs could help. You can try to match like what you want with what you have, and then you put a grade or a mark on this. So again, I try to map this, and this font was again like here had a kind of a big X height, so around this area, like in the near the middle part, but slightly to the right, and a little bit to the not so to the top, rather at the bottom of the graph. So here. And then I realized that evaluating font is matching specification versus requirements. So in other words, what you drew versus what you wanted to draw, which could be useful for tech designers, because of course teachers are not the only ones who evaluate types. You can do it yourself, and most users actually do that. So again, a spreadsheet showing what you can do, and this exercise helped me to draw a few conclusions. And of course, the first very obvious is that some things can be measured, some other things cannot. But it's nice to try. It's nice to just not to conform with what you know, that you can use words, and that you can measure things, and you can compare them, and that perhaps there are of course more complicated ways, but also interesting ways to select and to evaluate type. There is one thing that was it meant a challenge for me, which is the available data, because then if I couldn't use Penossi numbers, I had to make my own measurements. And Penossi numbers are okay, but they have a big problem, which is that they are very limited. and they don't describe with the richness that a measurement can. So it's quite hard to use this Penose information. But it was interesting to study the Penose system, and I think if all tech designers would study this thing a little bit, perhaps the measurements might not be necessary. It could be more refined. It could be very useful for not only substituting fonts but also selecting fonts. This has something to do also with classification systems. So I think it could be tested using this approach. And there is one more thing, which is that the implications of this. If there is really a way, or we can design an application or something that helps us compare typefaces like this, and helps us deal with big amounts of information in using parameters, I think the implications are huge, because there are many things that we can do automatically. Thank you for listening.
Did you look at Panos 2 or Panos 1?
I have no idea. I have no idea. Because
there was a second Panos system, which is more advanced.
Okay, good to know. Thank you. I had no idea. How refined is it? Does it have like more variables per parameter? Or?
Say there was like the stem parameter, or the serif parameter, and you could say like type 3 or type 4 in Panos 1. In Panos 2, you could say it's between type 3 and type 4, 60%.
Okay. Well, nice to know. Thanks. Any other question?